Well, Starrag's got vast experience in spindles. We manufacture them in-house, so we've got complete control of the design process. So they're designed for longevity, but they're also designed to be manufactured and built to a cost. It's no good over-engineering and overpricing because that would make the machines too expensive. So all of these things have been considered.
So I'm here today with Lee Scott from Starrag UK. We're talking about the compact range from Heckert. Now, if you've been following our YouTube channel, you'll know we're doing a series of short videos about the technologies on this machine, but always reiterating the fact that these are affordable to all, regardless of the type or size of company that you are. Lee Scott, spindle technology, hugely important, labelled productivity, process reliability and quality from Heckert. Can you maybe tell us why spindles are important and should be considered, in a very detailed way?
Sure. The most important thing with any process, any cutting process, is the tool chip interface, which is the cutting tool, the tool holder, which of course directly feeds into the spindle where we start. So it's imperative that customers buy the right spindle type to suit their processes. And
does that not happen often? Do you find that people just go, I need a spindle, and they don't take into consideration some of the technology in the spindle that can alleviate potential issues further down the line?
Well, I think most machines are purchased because they're there, they're available, it's got that spindle, people just buy them. They've then bought a compromise for the next 10 or 20 years, the life of that machine. So what we try and do is we look at the product, we look at the material and the process, the type of tooling, what is today's product and what's possibly required in the future. Then we start recommending spindle, then we start building the rest of the machine around that.
Okay, so what would the options be available on the Heckert product? And we'll put some details over the screen as to all of the options of spindles, but if you just give us maybe the shortened version.
Well, shortened version would be, there's typically two sizes, so a HSK 63 or 100 or a 40 or 50 taper spindle would be the two sizes. In terms of the range, there's a motor spindle option that goes up to 10,000 up to 30,000 revs, and then there's a gear spindle range from 6 up to 12,500 revs.
Longevity of spindle is critical. What technologies are these spindles equipped with that make sure they last the test of time, regardless of material types?
Well, spindles are absolutely important. The longevity of spindles is critical. The spindle's got a hard job to do. They're in a harsh environment, often they get bumped. So we manufacture most of our spindles across Starrag Group. We buy a few in, but not too many. So within the spindle design, we consider the bearing size. We use a very large bearing. We have a vibration sensor in all the spindles on these machines, so we can measure the harmonics and the vibrations through the cutting process. We can also measure whether a tool is running out of true and it's got an imbalance, because that's going to obviously affect the life of the spindle. We feed that data back through the HMI to the operators. So we can have long-term grease or an oil air, a lubrication system. And we've also got water-cooled spindles so that we're not overheating the spindles, which again has an effect on life and performance.
You mentioned that these machines, and we've said it throughout this series of videos, these are affordable to all manufacturers now, which maybe the brand has been overlooked in the past but shouldn't be now. How do you manage to give such depth in the technology at such an affordable price?
Well, Starrag's got vast experience in spindles. As I said earlier, we manufacture them in-house, so we've got complete control of the design process. So they're designed for longevity, but they're also designed to be manufactured and built to a cost. It's no good over-engineering and overpricing because that would make the machines too expensive. So all of these things have been considered.
And now what about the options on the spindles for things maybe not just like what we see here, straight milling?
So what you're looking at here is a standard configuration, motor and gear spindle, many different options as I already mentioned. Then also you've got traversing spindles, so the spindle can extend like a quill if you like. Or we've got what we call the DBF, where we can move the spindle off centre plus or minus. So we can put a turning tool in an out face or overturn or produce a bottle shape if you like, if it's programmed. Or we can drive a tool changeable out facing device either mechanically or electronically. So there's many different things you can do with the spindle itself.
Now, of course, we're looking at a horizontal machining centre here, 5-axis machine, but there's a turning option as well. So how does the spindle get configured in order to achieve that, and how does it maintain tolerance and performance in that area?
Well, that's a good question. For the T machines, the T is for turning. So we have a HSK 100 spindle interface that locks obviously in position for turning, disengages from the bearing, so you're not damaging the spindle when you're intermittent turning, if you like. And also we use a different kind of tool holder where the dog tolerance is tighter, so that as you load your tools in for turning, you get the orientation correctly as well. That's how we manage turning.
Thought of everything. Okay, we're going to be doing further videos on the HMI system here, the control system, but one of the screens here is about minimising vibration. That's so important, isn't it, when it comes to spindles? How do you go about that?
Well, sure it is, and as I said earlier, we measure vibration through a sensor in the spindle, and then we read that back to the operator. We can even measure vibration that you can't see on your component and tell you whereabouts it is in your NC program. You might be getting bad tool life and you don't know why.
One point from me would be the difference between power and speed. How do you manage to create and craft a spindle that can kind of give you almost the best of both worlds? Or am I wrong in saying that?
No, you're absolutely right to say it. And again, this goes back to design. We know with today's cutting tools what the power torque requirements are within a certain size range of tool and what we would expect to produce on a machine of this size. So we make sure with each of the spindle designs that we hit the specific power torque curves required for that particular material or application.
And is there a spindle or is there technology that would mean you can equip this machine so it is capable of machining the different types of materials that we all know differ in different industries? Is there one that fits all, or one that is kind of the benchmark that you'd go to?
I think that's a really good question, and that's a question really for the subcontract market where they don't know what they're going to be making long term. So high-speed aluminium, 30,000 revs, brilliant if all you're going to cut's aluminium, or you go very high torque, low speed if all you're going to cut's titanium or Inconel. Somewhere in the middle around the 10, 12, 15,000 rev mark, we offer machines with very high speed, very high torque. So you can cut aluminium one day, you can cut steels or even titaniums the next day.
And what are the problems that manufacturers might face if they don't invest in a machine that has a quality spindle, that has some of the points that you will, in fact, all of the points that you allude to? What issues may they face with their machine tool?
Well, it's quite simple. They will face the inability to optimise the productivity and profitability going forwards for the life of the machine. If you buy a machine with a compromised spindle, you've compromised the amount of money you can make from that machine forever.
So this is one of the most important aspects of a machine tool creation or purchase, isn't it?
I think it's where the discussion should always start.
Good stuff. Okay, this is the compact range from Heckert, available from Starrag. A fairly new range of machines. There's a series of videos on our YouTube channel, on our MTDCNC website, that talk about all aspects of this machine, all of the technologies and everything that makes this machine what it is from the ground up. This one's been all about the spindles. Thank you very much, Lee.
Thank you.